Hello, guys. Let's talk about ions. So, what is an ion? An ion is an atom or a group of atoms that has an electrical charge. When at least one electron is lost, cations are formed, and cations are positively charged. When at least one electron is gained, anions are formed, and anions are negatively charged. So let's take a look at an example and let's try to figure out whether we make a cation or an anion. So let's start with a sodium atom and a atom. So in a sodium atom, we are going to have 11 protons in the nucleus, and if it's neutral, we are going to have 11 electrons around this. So 11 protons and 11 electrons around it. So sodium atoms are actually tend to lose electrons. So lose one electron. What will happen on the other side? On the other side, I'm going to form an ion that is still going to have the same number of protons, so 11 protons, but this time I will have only 10 electrons. What is the charge on the formed sodium ion? Well, I can figure it out if I take 11, that's the number of my positive charges, and I add to it the number of negative charges, which is minus 10, right? So basically 11 minus 10 is going to give me 1 plus. So I made an Na plus ion. This is the sodium ion. Okay, let's take a look at another example. Let's start with the chlorine atom. And chlorine actually has 17 protons and 17 electrons when it's neutral. So, protons and the electrons around it. So I said 17 protons and 17 electrons. Okay, so chlorine actually likes to gain electrons. So if it gains one electron, then on the other side, I'm going to still have 17 protons, but at this time, 18 electrons. What is the charge on my chlorine atom? So I can go and calculate it. 17 plus minus 18 will going to give me minus 1. So the charge on this ion is minus 1. So this is called the chloride ion. Okay, now let's try to figure out which one is a cation and which one is an anion. So cations are always positively charged. Which one is my positive one? It's the sodium ion. So Na plus is a cation and Cl minus because it's negatively charged, and anions are always negatively charged, going to be my chloride ion, Cl minus ion. So the way how I try to remember this is when I think about cations, I think about cats. And well, I used to say that cats are positive, but cats also have paws, right? So since they have paws, cat positive, cations are positive. I hope this makes sense. Also, you can remember that anions, a negative ion, negative, ion. Okay, so anions are negative and cations are positive. So let's try to take it a couple of examples and try to figure out what is the charge on different ions. So we looked at sodium, and I told you before that all the elements in the periodic table would like to be like the noble gases. So where are our noble gases? These are our noble gases right here. At the very end of the periodic table, this is group 8A. That's the number of the main group. Okay, so sodium wants to look like the closest noble gas to it. So if I have sodium is Na, right? How many protons do I have in a neutral sodium atom? 11, right? Because of this number 11 right there. I know that. Which noble gas is the closest to sodium in its atomic number? Did you find it? It's indeed neon, right? Neon has 10 protons. And if it's neutral, then it's going to have also 10 electrons. So sodium is like, hey, I want to be like neon and I'm pretty close to it. I have an extra electron, so I want to lose it. So indeed, all these elements between the alkali metals are want to have a charge of 1 plus by losing 1 electron and getting to the electron configuration of a noble gas. And we are going to learn way more about electron configurations later. All right. What about chlorine? So chlorine is right here, right? And we said that chlorine likes to gain an electron. So which noble gas is closest to chlorine? It's argon, right? So argon has 18 protons and also when it's neutral, 18 electrons. Chlorine has 17 protons and when it's neutral, 17 electrons. So for chlorine to become the most similar as possible to argon, it has to gain an electron. So halogens are going to have an actual 1 minus charge all the time. Okay, so this is quite interesting. Um, Keep in mind that we are going to have elements, especially in the middle of the periodic table. So these are our transition metals that can have different charges, okay? So they don't always get to the same number of electrons as noble gases have. But there are some of the groups that actually going to obey these rules, and it's really good to know these rules. And it's really useful to know these rules. So let's take a look at some examples. What's up with potassium? So where is potassium? Let's try to find it in the periodic table. It's number 19, right? So which noble gas is closest to potassium? Argon, right? It's number 18. So you can see that the difference between potassium and argon is 1 single proton. Argon has 1 less proton than potassium. So the charge on potassium should be 1 plus because potassium will want to lose that electron to have the same number of electrons as argon. Okay. Let's take a look at oxygen. Where is oxygen in the periodic table? Did you find it? So oxygen is element number 8. Which noble gas is the closest to oxygen? Neon, right? With 10 protons and 10 electrons. Oxygen has 8. So if oxygen would like to become neon, it has to gain 2 electrons. While it's gaining 2 negative charges, it's going to get a charge of 2 minus. I hope it makes sense. Okay, let's look at calcium. Where is calcium? Calcium is element number 20 right here, and it is an alkali earth metal. Which noble gas is the closest to calcium? Again, argon, right? It's number 18. Calcium is number 20. So what would be the easiest way for calcium to have the same number of electrons as argon has? It has to lose 2 electrons. So to go from 20 to 18, as it loses 2 electrons, right? It loses 2 negative charges. So it's going to have a charge of 2 plus, okay? What about fluorine? Here we go. Where is fluorine? Fluorine is right here, number 9, and this is a halogen, and we talked a little bit about halogens already. So fluorine has neon as the noble gas closest to it. So for fluorine to have the same number of electrons as neon, it has to gain an electron. So it's going to have a charge of 1 minus. Okay, so I said that alkali metals are going to have a charge of 1 plus. Alkali earth metals are going to be 2 plus. Okay, so remember that. Also, oxygen is always going to be 2 minus, and now we can see that there is a trend emerges. So all metals on the left side of the table are going to have positive charges, and all nonmetals on the right side of the table are going to have negative charges. Okay, so nonmetals are gaining electrons, metals are losing electrons. Okay, so I hope this makes sense. Let's take a look at another example. What is the symbol and the mass number for an ion of sulfur that contains 16 neutrons and 18 electrons? Okay, so first of all, we have to find sulfur in the periodic table. What is the symbol of sulfur? It's element number 16, right? And it's a symbol of S, capital S letter. Okay, so how do I figure out the mass number? For the mass number, I need to add the number of neutrons to the number of protons. So I know that I have 16 neutrons. So how many protons do I have in sulfur? 16 also, right? And I know this from the periodic table, from its atomic number. So 16 plus 16 will give me 32, and that is the mass number. The mass number is given as a superscript before the element's symbol. All right, I also have to give a charge. So I know that I have 18 electrons and I have 16 protons. So in order to calculate the charge, I can do the following. 16 plus minus 18, right? This is the protons. This is the electrons. It's going to give me a charge of 2 minus. And here's our answer. Okay, let's take a look at another example. What is the symbol and the mass number for the ion that contains 26 protons, 30 neutrons, and 23 electrons? Okay, so first of all, I have to figure out which element is this. How do I know which element is this? I will know it from the number of protons. Since I have 26 protons, I'm looking for element number 26, and that is actually iron, right? So the symbol is Fe. Okay, in order to calculate the mass number, I have to add the number of protons to the number of neutrons. So 26 plus 30 will give me 56. That is going to be my mass number. And in order to calculate the charge, I have to see the number of protons and the number of electrons. So I have 26 protons and minus 23 electrons. So that is going to give me a charge of 3 plus. And this is my final answer. Okay, I hope this makes sense. See you in the next video.